Okay, so this is going to be a video, another derivative rule video about the product rule. And basically what this says is if you take the derivative of f of x times g of x, so the product of two functions here, that's why it's called the product rule, with respect to x, so the derivative of a product with respect to x of two functions, it's equal to f prime of x times g of x plus f of x times g prime of x. And what I'm going to be doing in this video is proving why this rule works. So the first thing I'm going to do is I'm going to fill in our definition of what a derivative is. So we have f of x times g of x. We need to instead write f of x plus h times g of x plus h minus our f of x times g of x all over h. And this just follows our definition of what a derivative is. Now we have to do kind of something a little tricky here because we want to make sure that these f's are together and these g's are together. So what I'm going to do is I'm going to add another term, and this will make more sense once it's all worked out. And since I added this term and everything has to be equal, I'm also going to subtract it as well. We're just adding it because we're going to be using it in the equation. And then I'll connect the line right here. Okay, so the next thing we're going to do is we're going to combine the f functions. Because I added these new terms, I can simplify this numerator. So what I'm going to do is move these terms around a little bit. It's adding and subtracting the numerator so the order won't matter. So I'm going to take this first term, this f of x plus h times g of x plus h, and subtract it by this f of x plus h times g of x. Then so basically this term and this term are gone because they're used in this next line. So I'm just getting rid of them so I can better organize myself here. Next, I'm going to combine this f of x plus h times g of x with this minus f of x g of x. So I'm going to do plus f of x plus h g of x minus f of x g of x. Now this is all going to be over h. Okay, I'm going to factor out this f of x plus h here. Simplify it a little bit more. So you will have f of x plus h times Alright, so what I'm going to do next is factor out this f of x plus h here and this f of x plus h right here. And you will end up with f of x plus h times, and I'm going to use brackets here just to keep things a little bit more organized, minus g of x. So if I distribute this f of x plus h to these two terms, you'll get this and this. So what I'm going to do is I'm just going to get rid of this because I don't want to see it anymore. I just want to focus on the rest of the problem. Next, I'm going to do the same thing with these two terms right here, only I'm going to be factoring out the g of x this time because g of x is in both of these terms. So I'm going to have g of x, bracket here, f of x plus h minus f of x, bracket, and this all has to be over h again. Okay, hopefully you can see this, the little trick here and why we needed to do this. The main thing is because this right here is equal to g prime of x. If you look at it, the limit of this is our definition of what a derivative is. So you end up having this, f of x plus h times g prime of x based on this right here. So you'll end up having the limit as h goes to 0 of f of x plus h times g prime of x plus g of x right here But you'll notice the same thing over here. We have this divided by h is equal to f prime of x. So I'm just going to write f prime of x. It just follows what our definition of a derivative is. The limit as h goes to 0 of f of x plus h minus f of x over h. That's our definition of a derivative. So you end up having f prime of x. Now, because we're not dividing by 0 anymore, because we got rid of this h here by simplifying these two terms, I can plug in the 0 for this f of x plus h, which means that h just goes away, and you end up with f of x times g prime of x plus g of x times f prime of x, which basically proves what we have up here for the product rule. So if you have any questions on the product rule or anything that I wrote up here, let me know.